This drawing looks correct, but it can cause 10,000 manufacturing mistakes. The problem? No proper GD&T. Hi everyone, welcome back to the channel. In this video, we are going to learn GD&T in SOLIDWORKS step by step. If you have ever struggled with feature control frame, position tolerance, flatness, perpendicularity, or datum reference, this video will make everything clear. We will briefly understand what GD&T is, model a simple part, create a drawing, and apply real GD&T symbol in SOLIDWORKS. Let's get started. First of all, let's talk about what is GD&T. GD&T stands for Geometric Dimensioning and Tolerancing. It is a symbolic language used to define form, orientation, location, and runout of feature. Instead of just saying diameter is 20 plus minus 0.1. We can say the hole must be within this cylindrical tolerance zone relative to these datums. GD&T gives more precision, better communication, less manufacturing mistake, better quality control. Now let's jump into the SOLIDWORKS. In SOLIDWORKS, we will create a simple plate with a rectangular base, two mounting holes, one central precision hole. Now let's go to the part. In a top plane, I create a rectangle with the dimension 120 millimeter and 80 millimeter. Extrude that 10 millimeter. Again, sketch on the top face of the rectangle, create a two symmetric hole with the diameter 10 millimeter. .35 millimeter distance from the center. Make the center point of the hole and origin horizontally and create a center line. And make mirror of this circle. From features, extrude cut both holes. And again, create a sketch on the top face. Create a circle with the diameter 20 millimeter. And create extrude cut. Save the part. Now let's create a drawing. From file, go to the file, make drawing from part. Create your sheet format and size. For example, I create a A4 landscape. Create a top plane, right and left. And also we can create an isometric view of our part. And after that, add basic dimension, first length, hole diameter, and hole space. At this position, we can add dimension tolerance with create on the dimension, and from tolerance, we can add our tolerance, for example, symmetric, plus minus, for example, 0.1. Here, we have dimension tolerance. Now we want to add geometric tolerance in our drawing. GD&T always start with datums. Datum A from annotation, datum feature, We use datum A for this side. This is our primary datum, and after that, use this side of rectangle for datum B, and this side back of our rectangle for datum C. Also, we can change our name from here, label setting. Now we have a full datum reference frame, A primary, B secondary, and C tertiary. Primary controls 3 degrees of freedom of our parts. Secondary datum B controls 2 degrees of freedom of our parts. And C tertiary controls 1 degree of freedom of our parts. This locks the part in space. Now let's control the location of two mounting holes. From annotation, geometric tolerance, and click in hole. And we have actually 14 symbols for control each of the tolerance. I click on position tolerance and input our range, for example 0.2, and after that for position tolerance we need add datum A, and actually we can add another datum B, and click done. Here we have a position tolerance for this hole. Now for the contour of the bottom surface, we apply flatness. For that, from geometric tolerance, click on this face, add symbol of flatness, and input tolerance zone, for example 0.01. And flatness does not use datums. It controls surface variation between two parallel planes with this dimension apart. Click done. This means this side of our parts can have variation between two plates with this dimension. Now let's control the central hole. For this central hole, I input perpendicularity, apply, for example, 0.1 millimeter, and add datum. This needs perpendicular with datum C. This ensures the whole axis is perpendicular to datum C within 0.1 millimeter tolerance zone. For manufacturing process, this means flatness, means surface grinding quality, for perpendicularity, for assembly fit, and for the position, the location of these two holes. GD&T is not just simple, it affects cost, inspection method, functional performance. And at the end, I want to tell you the common beginner mistake. For example, using flatness with datums. We never use flatness with datums. Forgetting to define datums first. As you can see, we first use datum first in drawing. Not understanding functional design intent. Remember, GD&T should reflect functional requirement, not decoration. In this video, help you understand GD&T very simple in SolidWorks. Like, comment your question, subscribe for more mechanical design tutorial. Thanks for watching. See you in the next video.